Hi everyone, here's another question that someone has posed to me, and this is asking determine the intervals where the function is concave up from 0 to 2 pi, and it's off of the chapter 3 review that I gave you. I'm going to try to link that file there in the chapter 3 stuff if I already haven't done so that if someone has lost the review or whatever can do that. And I also I'm going to put my answers to the chapter 3 review up also on Canvas. Okay, so this problem, it's asking for concave up, so that means I'm going to have to find the second derivative in order to answer that question. So that's the first thing that I'm going to do is find the derivative. Here, this right here is a product rule. So u equals x and v equals sine of x. So u prime equals 1 and v prime equals cosine of x. So the derivative, crisscross applesauce here, is x cosine of x plus sine of x. And all I've done is find the derivative of that piece. Now I'm going to find the derivative of this piece and put it here. I don't have to use any fancy rule for it. It's just 2, which is a constant, so it just holds still. So I can put the 2 down here, times the derivative of the cosine. And the derivative of the cosine of x is negative sine of x. So this is going to be negative 2 sine of x. And then nice is that these combine like terms. So I'm going to do that and clean this up a little bit. So I have x cosine of x minus sine of x, right? 1 sine of x minus 2 sines of x is negative 1 sine of x. Now what I'm going to do is find the derivative again, because I need to do that to find the concave up, they said. So the second derivative, that's why I wanted to write in pencil. I'm going to get a good eraser too. That's my next plan. In here, my studio, I have a studio here. I laugh to myself that anyone is watching these. Maybe I'm enjoying making them though. So the second derivative, crisscross applesauce. So I get negative x sine of x plus cosine of x. So that was just that derivative there of that product rule. And now I'm going to take the derivative of negative sine of x, and that's equal to negative cosine of x, right? Because the derivative of sine is cosine, and the negative just comes along for the ride. And that's really nice because that's 0. So I get that my second derivative is equal to negative x sine of x. And we want to know when that second derivative is equal to 0, because that's going to give us the places of possible changes in the concavity. So, negative x sine of x equals 0 when negative x equals 0, when x is 0, or when sine of x equals 0. And don't forget that we have an interval from 0 to 2 pi. And in fact, it looks like it doesn't include 0 and it doesn't include 2 pi. It's like it's open. Right, and so let's see, this could be at pi, right? And that's really out of the domain. Okay, so if it had been in the domain, then it would have been an endpoint. And so now we're looking at where the concavity is going to change. So here's 0, right? And I'm just inside of 0. And here's 2 pi. And I'm just ending just before 2 pi. And I have my my place where the concavity could change at pi. The other place I should be worried about is where the second derivative is undefined. I failed to mention that because it's never undefined. This is never undefined. And so I just want to make sure that I let everyone know that I was thinking about that, just didn't get it written or get it said. Okay, so now I'm going to test. And I had this question, and they were asking directly about an inflection point. What if when I do my test, I get 0? Because we know that if we test and we get positive, it's concave up. And if it's negative, it's concave down. And if you test and get 0, that means that you've tested an inappropriate point. Because you should not be testing anything that would make the second derivative 0. Because everything that you should have, those critical points that make the second derivative 0 or undefined should be here on your number line. And you should be only testing things that are in between those critical points. So if you get 0, then that means you missed it as a critical point, maybe, or there's just some other mistake. So you shouldn't. It should either be positive or negative. So x equals, and I could check whatever I wanted. So I could check pi over 2. That would be great. And remember, I'm testing in the second derivative. So I want to know when the second derivative at pi over 2, what it's equal to. So it would be equal to negative pi over 2 times the sine of pi over 2. And all I care about is whether or not it is positive or negative, right? And I know the sine of pi over 2 is positive, and so times a negative, this is negative. And I would probably check something over here, like perhaps 3 pi over 2. So x equals 3 pi over 2 would be a possibility. And all I care about is whether or not it's positive or it's negative. So I would get negative 3 pi over 2 times the sine of, it's not going to fit, 3 pi over 2, having anxiety on whether it'll fit. And this is a negative, and remember the sine of 3 pi over 2 is a negative. So this is a negative times a negative is a positive. So if you get 0, or if you get undefined when you're testing between in the regions, you know that something is wrong. You have made some kind of mistake. And so positive over here. And they want to know when is it concave up, and that is right here, from pi to 2 pi. Where did the C go? And that's all they asked for that. Okay, thank you. And we'll get this one up and running. Bye-bye.